Hi, this is Dr. Goldstein, and I am going to talk about a very important property of quotients that applies to any kind of rational function. So anytime you have two real expressions A and B, the quotient A over B is undefined whenever the bottom expression B is equal to 0. So what this means, here's an example to show you what this means. If I have the rational function x squared minus 1 divided by x minus 1, in this expression, A is equal to x squared minus 1, so that's a real expression and it's in the numerator, and B is equal to x minus 1, that's another real expression and it's the one in the denominator. And so the original expression is going to be undefined whenever B is 0, so whenever x minus 1 is equal to 0. So in other words, whenever x is equal to 1, the original expression is undefined. So x squared minus 1 over x minus 1 is undefined when x is equal to 1. So that's what we're saying here. Anytime you have a quotient of real expressions, the denominator can't be 0. Okay, but, and this is where things get complicated. You could take this original expression and you could factor the numerator. So I could take x squared minus 1 and I can factor it as x plus 1 times x minus 1. And then I have this x minus 1 on the bottom. And I can cancel that x minus 1 on the top and the bottom. And so it looks like this original expression, x squared minus 1 over x minus 1, simplifies to just x plus 1. And what we notice in this simplification is that x plus 1 is not undefined when x is equal to 1. When x is equal to 1, x plus 1 is equal to 1 plus 1, which is 2. And so we look at this and we say, what's going on? On the one hand, our original expression is undefined. That's what we said on the last slide. We said that our original expression is undefined when x is equal to 1. But now, on this slide, we're saying that our expression is equal to 2 when x is equal to 1. So something has to be wrong in what we've done. And so let's take a closer look at exactly what is going on here. So the property here is we canceled. Remember, we had x minus 1 over x minus 1, and we canceled them. That expression is equal to 1 as long as x minus 1 is not equal to 0. Because remember, a over b is undefined when b is equal to 0. So this x minus 1 here, this expression is equal to 0 when x is equal to 1, so this is undefined when x is equal to 1. So x squared minus 1 over x minus 1, again you factor the top and you have x plus 1 times x minus 1 divided by x minus 1. These cancel except when x minus 1 is equal to 0, i.e. x is equal to 1. And so this expression is not always equal to x plus 1. It's equal to x plus 1 when x is not equal to 1. Again, that's when the denominator is not 0. But when the denominator is 0, it's undefined. And there's absolutely nothing that we can do about that. Okay, so in general, for any real expression a, if you have a divided by a, you can cancel and you get 1 as long as that expression is not equal to 0. But anytime that expression is equal to 0, you cannot cancel. You do not get 1. This expression is undefined. So again, in the context of our example, we could cancel our x minus 1s on the top and the bottom as long as x minus 1 was not 0. But anytime x minus 1 is 0, they can't cancel, and so the expression is undefined. So that is what is going on. So if you look at the work that we did when we had x squared minus 1 over x minus 1 equals x plus 1, and we said when x is equal to 1, x plus 1 is equal to 1 plus 1, which is 2, and we said, well, what's going on here? Our error was in this equal sign right there. It's more complicated than that. Again, when the denominator is equal to 0, you cannot cancel. Okay, let's see this property in action in context. So let's say that we had the expression x squared minus 1 over x minus 1, and we wanted to set that equal to 0 and then solve. So one way of doing this is to take this expression and factor the top. So I take the top and I factor it as x minus 1 times x plus 1 over x minus 1, and I say, okay, when is this equal to 0? So one thing that I can do, one method that's really useful, is I say, okay, the top is equal to 0. So the top, which is x minus 1 times x plus 1, is equal to 0 when x minus 1 is 0 or x plus 1 is 0. So when x is equal to 1 or x is equal to minus 1. But the bottom, which is x minus 1, is equal to 0 when x is equal to 1. And so what we just said in the last problem is our original expression, x squared minus 1 over x minus 1, is undefined when the bottom is equal to 0. So the idea here is normally, if I have 0 divided by some number, this is always going to be equal to 0. So that's why I broke this up into the top and the bottom. I say, oh, well, if I divide 0 by something, I get 0. So I'm looking for where do I get 0. I look at the top. So normally, if I have 0 over a number, it's equal to 0. But, and this is the same but that we just talked about on the last 2 pages, if I have 0 over 0, it's undefined. So for this problem, the whole fraction is equal to 0 only when x is equal to 1. So what we have is that x squared minus 1 over x minus 1 is equal to 0 only when x is equal to 1, and not, x is equal to minus 1. And not when x is equal to 1. So the top is equal to 1 is equal to 0 anytime x is 1 or x is minus 1, but the bottom is equal to 0 when x is equal to 1, and that's undefined. So I take that potential solution and I cross it out because that's where it's undefined. So this is our solution, just x equals minus 1. And this might seem overly complicated because you could just multiply both sides of this by x minus 1. Oh, except you couldn't, right? Because if you multiply both sides of this by x minus 1, so let's do some wrong work in the top corner here. If I multiply both sides by x minus 1, it cancels over here, which again what we've said is you have to be careful of that. And on the right-hand side you just get 0 and then you factor. And you end up with x is equal to 1 and minus 1. Again, that is wrong. Because what we said in our correct work is that when the bottom is 0, the expression is undefined, and it can't be equal to 0 when it's undefined. Okay, let's see another example. So let's say that we want to solve this expression, and I factored it already for you. So in this expression, if we look at the top, this is x plus 1 times x minus 1 times x minus 2, and that's equal to 0 when x plus 1 is 0, or x minus 1 is 0, or x minus 2 is 0. And so this is when x is equal to minus 1, x is equal to 1, or x is equal to 2. And the bottom, which is x minus 1 times x minus 2, that is equal to 0 when x minus 1 is equal to 0, or when x minus 2 is equal to 0. So when x is 1 or x is 2. At both of these values, our original expression is undefined. So I have to go back to where the top is equal to 0, and I cross out x equal to 1, and I cross out x equal to 2. And so my only solution is x equals minus 1. So again, if I multiply both sides by the denominator and canceled, I would not get the right answer, because I'm getting rid of the fact that the left-hand side is undefined when x is equal to 1 and x is equal to 2. So again, the general principle if you have a real expression a over b and you want to know when it's equal to 0, this is equal to 0 when the top is equal to 0 and the bottom is not equal to 0. And in practical purposes, what that means is that you have to get rid of any values where the bottom is equal to 0.